availing yourself in today's class, and welcome in our today's class. In our previous class, we tried to derive the derivative of given functions. For example, we saw generally that if you have a function like the one we have here, y equals to a, x raised to n, then the derivative of this function will be dy dx equals to n a x n minus 1. This is the general formula which you use whenever we have any given function and we want to have its derivative. So today, I want us to move further and consider the equation, or how we can get the equation of the tangent to any given curve. How we can get the equation of a tangent from any given curve. So we're going to have a function here, given a function, and a tangent is that point that touches a curve. It does not cut, but it touches a curve at any given point. This line is what we're calling a tangent, because this line is a straight line and it is touching. That straight line is just touching a given point. And it's very important that we have that point. And we will want to get the tangent of this, the equation of this tangent, and this point, it's 2, 1. The point there, it's 2, 1. So we will want to have the equation of this tangent, this straight line. We will want to have the equation of that straight line. So the knowledge we have about the derivatives or the gradient function which we calculated in our previous lesson, it will assist us to get the equation of that straight line that touches this curve on that given point 2, 1. Now, this is how we proceed. This is how we proceed in order for us to get the equation of the tangent at that the equation of the tangent at that particular point. We first of all, so we have the solution here. We first of all have to get the gradient function. Gradient function of the curve. The gradient function of the curve. So the gradient function of the curve is going to be dy dx. So we have this function x squared plus 2. So the gradient function will be equal to 2x. And you remember we say that when you are doing the gradient function, we have this point coming down and we subtract 1 from there. So the dy dx, the gradient function for this function we are having, is 2x. Now we are going to proceed and now get the gradient at that particular point. The gradient at that particular point, we are going to have 2, and then we substitute the value of x. So the value of x is 2. We substitute there the value of x, and we are going to get the gradient at that particular point is 4. The gradient at that particular point is 4. And we know now that in order for us to get the gradient of any given line, in order for us to get the gradient of any given line, from the previous knowledge which we have, we know that the gradient of any given line is given by change in y over change in x. And we know that this point is 2 there, and that point is 1. So we know that y minus 1 all over x minus 2 should give us the gradient which we got as 4. Should give us the gradient which we got as 4. Now, you do the cross multiplication, you get that y minus 1 equals to 4. You introduce a bracket, x minus 2 there. Then y minus 1 equals to 4x. Now you open the bracket, 4x minus 8. Then here you collect like terms and you get y equals to 4x plus 7. That is the gradient of this line, the equation of this line which we are having. The equation of this line which we are having is this one here. The equation of this line which you are looking for is here. So we know that now we can get the equation of a line given a point on the curve. We start by getting the gradient function of that curve, and at that point we get the gradient at that point. Then after getting the gradient at that point, then you proceed to get the equation of that tangent that touches that point at that particular point. Then that's how we do it. Another example which I'm going to give today is find the equation of the tangent to the curve y equals to x cubed plus 2x plus 1 at 1, 4. Repeat. Find the equation of the tangent to the curve y equals to x raised to 3 plus 2x plus 1 at a point 1, 4. Solution. First of all, we get the gradient function, which we get by differentiating the equation. So dy dx equals to 3x squared plus 2, and of course here 1 will be dropped from that, so the gradient function will be this one. So the gradient function will be that one. So in order for us now to get the gradient of this equation at this point 1, it's going to be 3. We substitute in 1 because the value of x is 1, and we square it plus 2. So the gradient here will be 3 plus 2, and the gradient will be 5. So we found that the gradient is 5. You have found that our gradient is 5. So we move on now to calculate the equation. We move now to calculate the equation of the tangent. And we know that the equation of the tangent, which is a straight line, is given by change in y over change in x. Now this one is going to be y minus 4 all over x minus 1 equals to 5. Y minus 4 all over x minus 1 equals to 5. You do the cross multiplication and then you get y minus 4 equals to 5 x minus 1 there. Then y equals to, first of all, y minus 4 equals to 5x minus 5. So that y will be equal to 5x minus 1. That will be the equation of the tangent. That will be the equation of the tangent. Y minus 5x. Y equals to 5x minus 1. Y equals to 5x minus 1. Thank you. There's another part I want us to deal with, is the equation of a normal. Equation of a normal. This line here is what we are calling a normal. So the normal and a tangent, they meet at that point at 90 degrees. They are perpendicular to one another. And you know that if this M1 is the gradient of our tangent, then when you multiply with M2, which is the gradient of our normal, then the solution is going to be equal to -1. If you take the gradient of the tangent and multiply with the gradient of the normal, then your solution is going to be -1. We are going to use that principle. Then we are going to be able to calculate the equation of any given normal to that tangent. An example. Find the equation of the normal to the curve y equals to x cubed minus 2x minus 1 at a point 1, 2, 1, -2. Find the equation of the normal to the curve y equals to x cubed minus 2x minus 1 at a point 1, -2. The first thing, as usual, you're supposed to do is find the gradient function. And how do we get the gradient function? We get the gradient function by differentiating the function that have been given. So dy dx of this function equals to 3x squared minus 2. 3x squared minus 2. These 3 will come down here and we'll subtract 1 from that. Then we have a 1 here that is going to come down here. Then we subtract 1 from that one. So the function, the gradient function will be this one. So the gradient function will be that one by differentiation. So what we are going to do now, we are going to have to get the gradient of the gradient of the tangent. Gradient of the tangent. Gradient of the tangent, which is going to be 3. We look at the point, the coordinate of x. The coordinate of x is 1. So we substitute there by 1, then we square minus 2. So this one is going to give us 1. This one is going to give us 1. So the gradient of our tangent is 1. Then we proceed, because now we know the gradient of our we know the gradient of our tangent. Then we proceed now to get the other part of the equation, because we have known the gradient. Now we proceed now to get the equation of the normal. So here we are going to head m1 multiplied by m2 should give us -1. So we are having our gradient of the tangent, which is being 1, times m2 should give us -1. So m2 equals to -1. So the gradient of the normal, gradient of the normal equals to -1. Then we are going to proceed now to get the equation of the normal. So the equation of the normal is change in y over change in x. And we know the point here, y minus -2 all over x minus 1 should equal to -1. The point which we are looking at the gradient was 1, -2. So change in y over change in x should give us that. So this one is y plus 2 all over x minus 1 equals to -1. So y plus 2 equals to -1 x minus 1. So this one is y plus 2 equals to -x plus 1. So the equation will be y equals to -x minus 1. That will be the equation of the normal. That will be the equation of the normal. Y equals to -x minus 1. Example 2. Find the equation of the normal to the curve y equals to x cubed plus 4x minus 3 at a point 1, 2. Find the equation of the normal to the equation y equals to x raised to 3 plus 4x minus 3x at a point 1, 2. Solution. Find the gradient function, and we get the gradient function by differentiating the function given or the equation given. So this one is going to be dy over dx equals to 3x squared plus 4. The gradient function is going to be 3x squared plus 4. How do we get Now this is our gradient function. Now we take now the gradient function to get the gradient of the tangent. Gradient over the tangent. Gradient of the tangent at the point 1, 2. So we are interested in the point 1 because it is the x-axis coordinate. So this one is going to be 3. Then you substitute 1 where we have x plus 4. So the gradient is 7. The gradient of the tangent is 7. Now we proceed and now get the gradient of the normal. Gradient of the normal. Of the normal. Which is m1 multiplied by m2 should give us -1. So m1 is the gradient of the tangent, and we don't know m2 because it's what we are looking for. So this one is going to be 7 times m2 equals -1. So m2, which is the gradient of the normal, is going to be -1 all over 7. -1 all over 7. So the gradient of the tangent is 7, while the gradient of the normal is -1 over 7. Then we proceed. We proceed now to get the equation of the. We proceed now to get the equation of the normal. Now we know that to get the equation of the normal is change in y all over change in x will give us the gradient of an equation. So this one is going to be y minus 2 all over x minus 1 should equal to -1 over 7. Here it's going to be y minus 2 multiplied by 7 equals to -1 x minus 1. So this one is 7y minus 14 equals to -x plus 1. So this one is going to be 7y equals to -x plus -x plus 15. -x plus 15. So y equals to -1 over 7x plus 15 over 7. That will be the equation of our normal in the form of y equals to mx plus c. Thank you very much. For our assignment today, it's already here. We have assignment part A, part B, and part C. And the requirement of the assignment is find the equation of the tangent to the curve at indicated point. Find the equation of the tangent to the curve at the indicated point. A, y equals to x raised to 3 plus x raised to 2 plus 1, and the indicated point is 1 and 3. Part B, y equals to x3 plus 6x raised to 2 minus 3x plus 1 at a given point that is indicated is x equals to 0. And finally, part C, y equals to x raised to 4 minus 3x squared plus 2x, and the indicated point is x equals to 1. Do the assignment. After finishing doing the assignment, you are going to take the photo of the assignment and send to my WhatsApp account, which is on 0724 700 686. That's my WhatsApp account. You send your assignment to my WhatsApp account. I'll mark the assignment and I'll come back to you for our assignment on finding the equation of the normal. We have 3 questions. And the first question is, find the equation of the normal of the curve at given point. There. So the equation is y equals to 3x minus x squared at a point negative 2, 2. And another one is, part B of the assignment is y equals to x squared plus 3x minus 1. And you are finding the normal at the point 2, negative 3. And finally, part C, you are finding the normal of the equation y equals to x raised to 3 plus 3x raised to 2 minus 9x plus 3 at a point 1, negative 2. Please do the assignment and take the photo of the assignment and send it to 0724 700 686. I'll mark your assignment and then I will send it back to you to see whether you have done the correct thing. See you in the next part of our lesson in differentiation. Thank you.